Black holes are the most feared objects in the cosmos. But a black hole needs you to cross its event horizon before it can do anything to you. A magnetar does not need you anywhere near it. A magnetar does from across the galaxy what a black hole can only do from its event horizon. It reaches, it fires, it sends destruction across distances so vast that the light from its location takes longer to reach Earth than our sun has existed. And what arrives at the end of that journey is still powerful enough to blind our satellites, compress our atmosphere, and register on instruments as the most violent event ever recorded from outside this solar system. That was from 50,000 light years away. At the distance of the moon, it would not announce itself with a flash or shockwave. The magnetic field passing through your body would find the iron in your blood and respond to it the way a magnet responds to metal. Not slowly, not gradually, immediately. The eye in your cardiovascular system depends on to keep oxygen moving through you would be redirected before your brain processed that anything was wrong. You would not bleed. You would not burn. Your body would begin failing from the inside with no visible cause and no warning and nothing anyone near you could do to understand what was happening, let alone stop it. Then the burst itself would arrive, and what the magnetic field started would become the least of your problems. There are 30 confirmed versions of these objects sitting in this galaxy right now. They are called Magnetars, and they are the most aggressive objects the laws of physics permit to exist. Every star more than 8 times the mass of our sun ends its life the same way. After billions of years burning through its nuclear fuel, the outward pressure holding the star together against its own gravity collapses in under a second. The core implodes. The outer layers fall inward at a quarter the speed of light, hit the collapsed core, and rebound outward in a supernova, one of the most energetic events the cosmos produces. What gets left behind is a neutron star, roughly 20 kilometers across, more mass than our sun packed into something the size of a city. The density is so extreme that a teaspoon of its material weighs 1 billion tons. Think of it as the universe taking an entire star and compressing it down to the size of reading. A neutron star is already the most extreme stable object physics permits to exist. Then a small fraction of them do something worse. When the collapse happens fast enough and the conditions align, the resulting object's magnetic field reaches a strength that has no meaningful comparison to anything in human experience. An MRI machine, one of the strongest magnets we routinely build, generates a field of around 30,000 Gauss. A magnetar generates 10 to the power of 15. That is 100 billion MRI machines focused into an object 20 kilometers wide. At that field strength, the magnetic force stops behaving the way magnets behave in everyday life. It warps space-time in the immediate area around the object. It splits individual photons in two. It restructures the quantum vacuum itself. It is less like a magnet and more like a fundamental force of nature that has been turned up past any setting it was ever supposed to reach. And then occasionally, without warning, the surface cracks. A magnetar's crust is a rigid crystalline structure under unimaginable stress from the magnetic field threading through it. When that stress exceeds the structural limit, the surface fractures in what physicists call a Starquake. The magnetic field lines snap and reconnect in a fraction of a second, and the energy released in that moment fires outward as a gamma-ray burst. December 27, 2004. A magnetar 50,000 light-years away experienced one of these events. In 0.2 seconds, it released more energy than our sun will produce in 250,000 years. That burst crossed half the galaxy and arrived at Earth moving at the speed of light. Satellites went blind. The ionosphere compressed on the side of Earth facing the source. Instruments built to measure the most extreme events in the cosmos briefly went off scale. Nobody on the surface felt anything. That is what 50,000 light years does to a magnetar burst. It reduces the most energetic event ever recorded from outside this solar system to a footnote that most people alive in 2004 never heard about. The safe distance from a magnetar is not a fixed number. It is a sliding scale of catastrophe, and where you sit on that scale determines whether the object is a distant curiosity or an extinction event. At 50,000 light years, the distance of the 2004 event, A major magnetar burst partially ionizes the upper atmosphere, blinds satellites, and registers on instruments as the most powerful event ever detected from outside the solar system. Earth absorbs it. Life continues. Nobody on the surface notices anything has happened. Pull that magnetar to 10,000 light years and the numbers change completely. The energy arriving at that distance is sufficient to collapse the ozone layer on the side of Earth facing the source. Ultraviolet radiation floods the exposed surface. Crop failures, ecosystem disruption, a mass extinction event triggered by a star that was never visible to the naked eye. At 1,000 light years, the hemisphere facing the burst is not damaged. It is sterilized. The energy flux at that distance exceeds the threshold for complex biological survival on any exposed surface. Half the planet ends in 0.2 seconds, not in fire, not in impact, but in a silent wall of gamma radiation moving at the speed of light. At a few light years, the distance of our nearest stellar neighbors, the burst does not stop at the surface. It strips the atmosphere entirely. The planet is left as a bare rock orbiting a star that never knew it was dangerous. And at 200,000 kilometers, closer than the moon, you never reach the surface. The magnetic field gradient at that distance is strong enough to interact with the iron in your hemoglobin before the burst even fires. Your blood becomes the first casualty, not because of radiation, not because of heat, because the iron keeping you alive responds to the field the way iron always responds to a strong enough magnet. The closest sits roughly 9,000 light years away, well outside the sterilization threshold. Safely, for now, in the category of objects that can disrupt our satellites and compress our atmosphere without threatening life on the surface. But magnetars do not announce when they are about to fire. A starquake gives no warning signal that travels faster than the burst itself. The gamma rays and the first possible notification arrive at the same moment. The 2004 event was detected after it hit. Most are only detectable when they fire, and most have not fired recently enough for us to know they are there. The ones we have not found yet are not less real for being undetected. They are simply quieter.